Hi everyone, welcome to the fourth week of the junior cycle higher level maths. So this week we're going to be going through quadratic equations and algebraic fractions. So we've kind of built up to this so far. We've been kind of doing the more simple style equations, so we're going to look at the more higher level content today. So I'm just going to start by going through what a quadratic equation actually is, and this might seem very basic, but a lot of students can, I suppose, forget what a quadratic equation actually is. So that's probably one of the most important things that you need to know. Okay, so the first thing that we want to remember is that a quadratic equation is an equation with an x squared term. Now it can also have an x term and a constant in it as well. So I'm just going to write that out first. So a quadratic equation is an equation with an x squared term. And as I said, it can also have an x term and a constant. So an example of that would be if we had x squared minus 5x plus 6. So there's your squared term. There's your x term, so that's a coefficient of x, which is minus 5. So that's your x term. And your constant, which is 6. So that number doesn't change. So let's do a first example here now. So the first example for a quadratic equation is going to be verify. So verify means prove. So verify that x equals 2 and x equals 3 are roots of the equation x squared minus 5x plus 6 equals 0. So you've been asked to verify that. So the first thing we look at here is check and see, is this a quadratic? It is. It has an x squared term, it has an x term, and it has a constant. So that means that it's a quadratic. Now the question was to verify, so that means prove that x is 2 and x is 3 are roots of the equation. So what we're going to do is we're going to plug in x is equal to 2, we're going to plug it in here. So anywhere we see x, we're going to put in 2 instead. Okay, so for the first one, for x equals 2, so I'm going to write out my equation, which is x squared minus 5x plus 6 equals 0. So anywhere I see x, I'm going to put in 2. So it's going to be 2 squared minus 5 by 2 plus 6. Now what we're trying to see is when you do all this out, does it equal 0? And if it does equal 0, then you've verified it. So 2 squared is 4. 4 take away 10 plus 6. Now you can plug that directly into the calculator, but 4 take away 10 is minus 6. Minus 6 plus 6, it does equal 0. So that's verified. Now we need to check x equals 3. So for x equals 3, we're going to do the same thing again. So it's x squared minus 5x plus 6 equals 0. So anytime we see x, we're going to plug in 3. So it's going to be 3 squared minus 5 by 3 plus 6. And we're going to see, does it equal 0? 3 squared is 9. Minus 5 by 3 is minus 15 plus 6. So what you're going to do now is you're going to put this into the calculator or do it in your head. 9 take away 15 is minus 6. Minus 6 plus 6, it does equal 0. So that's now verified as well. So you've just proved that x is equal to 2 and x is equal to 3. They're both roots of the equation. Okay, so we're still on quadratic equations. So this brings me to my next example. So this is going to be example 2. And what you're being asked this time is going to be to solve x squared plus 3x plus 2 equals 0. Now up till now you've only had to factorise this much. You haven't had the equal 0, so there is just a little bit of extra work you have to do at the end. So the way we do this is we're going to factorise it first. So we factorise first. Okay, so it's going to be x squared plus 3x plus 2. So the way we factorise is we're going to get factors of 2, so 2 by 1, so they're the only factors of 2. And remember that they need to add or subtract to give you the middle number, which is 3. So we have a 2 and we have a 1, and we need it to equal 3. So we need to decide what signs need to go in front of the 2 and the 1. So if both of them are plus, you'll get a plus 3. At this point, we open up our brackets. We put x in the first, x in the second. We've gone with plus 2 and plus 1. So we know up to that point. Now, you are told that it's equal to 0. So we're going to write down that this equals 0. So we're going to do them separately. We'll do this bit first. So x plus 2 equals 0. So I want to get what x is. I want to get x on its own. So when I bring 2 over here, it becomes a negative. So it becomes 0 minus 2. 0 take away 2 is minus 2. That's one solution. And then we're going to do this one. So x plus 1 equals 0. So x is equal to 0, take away 1, because when 1 comes over an equal sign, it changes sign and it becomes minus 1. So x is equal to minus 1. And there are your two solutions, and what you'd write out then for that is the roots of the equation. So the roots of the equation, are x equals minus 2 and x equals minus 1. So that's example 2. I'm going to go on to example 3 now on the next slide. Okay, so we're still on quadratic equations, and we're going to go on to example 3 now. So for example 3, you're asked to solve a squared plus 7a is equal to 8. Now with this one, you have to use your head a little bit. You will see that you have a squared term, you have an a term, so an a squared term, an a term, and you have a constant, but there's something wrong with this equation. The constant should be over this side, and it should be equal to 0. So what we need to do now is bring the constant over to this side and let the whole thing equal 0. So when I do that, it's going to become a squared plus 7a. So I'm bringing the 8 over here. It becomes minus 8 equals 0. And you would get your marks there just for knowing what to do there to bring the 8 over the equal sign. So just as before, we're going to factorise first. So the way we're going to factorise, so it's a squared plus 7a minus 8. So we need factors of 8. So 4 by 2, 8 by 1. Now will either of those add or subtract to give me the middle number? The middle number is 7. So we need a 7. So 8 and 1 will work. So we have an 8 and we have a 1. So how do we get 7? So we have plus 8 minus 1. So we open up our brackets. A in the first, a in the second. We've gone with plus 8 minus 1. Now remember, we need to let it equal 0 because you were told this whole thing equals 0. And then when we continue, it's going to be a plus 8 equals 0. So a is going to be 0, take away 8, because remember the 8 comes over here when it crosses an equal sign. You want to solve for a. So a is equal to minus 8. So that's one solution. Then the other solution, a minus 1 equals 0. So a is equal to 0 plus 1, because the minus comes over here and it changes sign. So a is equal to 1. And that's your other solution. Again, I'm going to just write out the roots of the equation. Are a is equal to minus 8 and a is equal to 1. Okay, so we're on to example 4 now of quadratic equations. For example 4, the question is going to be solve y squared is equal to 5y. Again, this is a more higher level style question. Now, the same thing as before. We want it to equal 0. So in order for this to equal 0, we need to bring the 5y over beside the y squared. So if you don't see a sign in front of the number, we assume it's positive. So if that's positive, we bring it over the equal sign, it becomes negative. So it's going to be y squared, take away 5y is equal to 0. Now, this is not a quadratic, or quadratic trinomial, should I say, because we don't have a constant, okay? So for this reason, the only way that we can solve this is find the highest common factor, so HCF. So what is common to both y squared and 5y? And I think a handy thing to do here is write out y squared as y by y minus 5 by y equals 0. So what's common to both of those? So there's a y here and there's a y here. So I'm going to pull out y. So y multiplied by something equals 0. So what multiplied by y gives me y squared? Well, it's going to be y by y. So y is going to go there, minus y multiplied by what gives me 5y. So it's going to be 5 that goes in there. So it's y by y minus 5. Now this is the bit where we're taking it further. So one of your solutions is going to be y equals 0. So that's one solution. Now your other solution is going to be y minus 5 equals 0. So remember, you need to get what y is. So y is equal to 0 plus 5. 0 plus 5 is 5. That's your other solution. And again, this is HCF, sorry. So this is HCF, highest common factor. So you take out what's common. Okay, so we're on to example 5 now, which is the difference of two squares, and it's kind of extended because it's going to be equal to 0. So example 5, and you're going to be asked to solve 4a squared minus 25 is equal to 0. Now here it's the difference of two squares, but we need to rewrite the second part as a square number. And see, can we write this first part as well? We know that 2 squared is 4. So can we write 4a squared as a square number? So instead of having 4a squared, if we put 2a in brackets and we squared that, so 2a squared will give you 4a squared. So then it's going to be take away, so 25, so we know that 5 squared is 25. So now you have both of them in the correct format. The rule is open up your brackets. 2a goes in the first, 2a goes in the second, 5 goes in the first, 5 goes in the second, and the rule is plus with one, minus with the other. And what we didn't have before is that it's equal to 0. So that now means that 2a plus 5 equals 0, and 2a minus 5, 2a minus 5 equals 0. So we need to solve for a. So 2a is equal to 0, take away 5. So 2a is minus 5. So we want what a is. So a is going to be minus 5 divided by 2. So that's one solution, or you could say minus 2.5. So a is minus 2.5. Your other solution then is going to be 2a is equal to 0 plus 5. So 2a is equal to 5. So a is equal to 5 over 2. So then a is equal to 2.5. And that's your other solution. And that's how you solve that one. Okay, so we're moving on to the second half now, which is algebraic fractions. And we're going to start with a simple enough one just to remind us of how we're actually going to solve these. So example 1 is going to be simplify the following. So simplify the following. And it's going to be 3 over 4 plus 1 over 3. So you're asked to simplify that. Now the way we do this is we're going to find the lowest common denominator of 4 and 3. Okay, so we're going to find the LCD, or the lowest common denominator, of 4 and 3. So what do both 4 and 3 go into? The answer is 12. So I'm going to write it as a single fraction and put 12 on the bottom. 4 into 12 goes 3 times. So it's going to be 3 by the number on top, which is 3, plus 3 into 12 goes 4 times, and it's 4 by the number on top, which is 1. So then on top we have 3 by 3, which is 9, plus 4 by 1, which is 4 over 12. 9 plus 4 is 13, so the answer is 13 over 12. So that's very straightforward. That is no algebra in it yet. This is going to bring us to the next example, which will have algebra in it, which we're going to bring y's into it this time. So example 2 for algebraic fractions. And again, you're asked to simplify the following. So for this one, it's going to be y over 2 plus 4y over 3. Now, the exact same thing we're going to do. Find the LCD, so the lowest common denominator. So find the LCD of 2 and 3. We're going to write it as a single fraction. So what do 2 and 3 both go into? They both go into 6. So 2 into 6 goes 3 times, and it's 3 by y. So 3 by y plus 3 into 6 goes twice, and then it's 2 by 4y on top. So 2 by 4y equals, so 3 by y is 3y, plus 2 by 4y is 8y, and that's all over 6. So 3y plus 8y is 11y over 6. And you can't simplify that anymore. So the answer to example 2 is 11y over 6. Okay, so we're on to example 3 now. For example 3, you were again asked to simplify. So it's 5x plus 2 over 3 minus x minus 1 over 6. So same idea again, you're going to get the lowest common denominator. So the lowest common denominator of 3 and 6 is 6 because they both go into 6. So we're going to write it as a single fraction. So we're going to put 6 in the bottom. 3 into 6 goes twice, and it's 2 by the top bit, so it's going to be 2 by 5x plus 2 minus 6 into 6 goes once, and it's 1 by x minus 1. That's 1 by x minus 1. Okay, so the next line now, so 2 by 5x is 10x plus, that should be a 10, and then 2 by 2 is 4. So then minus 1 by x is minus 1x, and then minus 1 by minus 1 is plus 1. And it's all over 6. So now we're going to bring the x's together, so 10x, take away 1x is 9x, and then 4 plus 1 is 5. So 9x plus 5 over 6. And you can't simplify that anymore. So the answer there to example 3 is 9x plus 5 over 6. And you adapt the exact same method. You get the lowest common denominator first, and you write it as a single fraction and take it from there. Okay, so we're going to move on to example 4 now of algebraic fractions. And the more practice you get at these, the better. So for example 4, you're going to be asked to simplify. So simplify x minus 4 over 3 plus 3x minus 2 over 2. So that's what you've been asked to simplify. So again, let's get the lowest common denominator. So the lowest common denominator of 3 and 2. So what do both 3 and 2 go into? The answer is 6. So we're going to write this whole thing over 6. So 3 into 6 goes twice, and it's twice by all of this on the top. So it's going to be 2 by x minus 4 plus 2 into 6 goes 3 times, and it's 3 by 3x minus 2. So it's 3 by 3x minus 2. So we're going to multiply this out. 2 by x is 2x. 2 by minus 4 is minus 8. 3 by 3x is 9x. And 3 by minus 2 is minus 6. And that all goes over 6. So now we're going to put the x's together. So 2x plus 9x. I'll just write them beside each other. So 2x plus 9x minus 8 minus 6 all over 6. So 2x plus 9x is 11x. And minus 8 minus 6 is minus 14. And that's all over 6. And again, just double check you can't break it down any simpler. You can't. So 11x, 14 and 6, there's no number that goes into all three of those. So that's your answer for example 4 there. Okay, so I've pulled this question from a higher level exam paper, and we're going to go through it using the exact same method as I'm after going through there. So the question says to write the following as a single fraction in its simplest form. So let's look at the bottom. The bottom numbers, you can find the lowest common denominator of 3 and 4. So that's what we're going to write down first. So the LCD, so what do 3 and 4 both go into? So they both go into 12. Okay, so I'm just going to rewrite the equation. So it's x plus 2 over 3 minus x minus 3 over 4. So we need to get the LCD, or we've got it already, of 3 and 4, which is 12. So we're going to write this whole thing over 12. So so 3 goes into 12 4 times, so it's going to be 4 by x plus 2 minus, and then 4 into 12 goes 3 times, and it's 3 by x minus 3. So it's going to be 3 by x minus 3. So we're going to multiply everything out. 4 by x is 4x. 4 by 2 is 8. Minus 3 by x is minus 3x. Minus 3 by minus 3 is plus 9. And that's all over 12. So let's put the x's together. So 4x minus 3x and the numbers together. So plus 8 plus 9 all over 12. So then 4x minus 3x is x, or 1x. And 8 plus 9 is 17. So x plus 17 over 12. And that's the answer to that question. Okay, so I've also pulled a quadratic from the past exam papers as well. So we're going to solve this using the method that I went through with you at the very start. So the question is, so it's x squared minus 5x minus 6. And you're asked, be careful, it says solve and it's in bold as well, which means get values for x. So get values for x. Okay, so we need to solve. So we're going to factorise first. So what are the factors of 6 that give us 5? So we have 6 by 1 and we have 3 and 2. So I'm going to go for 3 and 2 and see does it work. So I have a 3 and I have a 2 and I need it to equal minus 5. So if I put a minus 3 and a minus 2, that'll give me minus 5. So if I open up my brackets and I put x in the first, x in the second, I'm going to put minus 3 with the first, minus 2 with the second. So we're going to let them both equal 0 because that's what you're told at the start. So x minus 3 equals 0. So x is equal to 0 plus 3. So therefore x is equal to 3. So that's one solution. And then the other solution, so x minus 2 equals 0. So x is equal to 0 plus 2. So therefore x is 2. And that's your other solution. So now you have it solved because you have two values for x, which is what you were asked for in the first place. I pulled this from the 2015 higher level paper. Now with this one, you have to use your knowledge of area and volume in order to solve the question. So a triangle has a base of length 2x centimetres. So this is the base here, it's 2x centimetres. And they're telling you that the perpendicular height is x plus 3. So the perpendicular height here is x plus 3. And they're telling you that the total area of the triangle is 10 centimetres cubed. What they want you to find is the distance x, so they want you to get a value for x. So the first thing I would do there is write out your formula for area of a triangle. So area of a triangle, and you'll get this in your log tables, is half the base by the perpendicular height. So that's just the sign for perpendicular. So I'm going to write this out again. So half the base multiplied by perpendicular height is equal to the area. So let's write out what we have. Do we have the base? We do. The base is 2x. Okay. So what's half the base? What's half of 2? It's going to be 1. So what's 2x? What's half of 2x is going to be 1x. So half the base is 1x. So 1x multiplied by the perpendicular height, which is x plus 3, is equal to the area, which is 10. So let's rewrite that. So x multiplied by x plus 3 is equal to 10. Let's multiply this out. X by x is x squared. X by 3 is 3x is equal to 10. Now you'll see a quadratic trinomial forming here. So what we need to do is bring the 10 over to this side and let it all equal 0. So it's going to be x squared plus 3x minus 10 equals 0. And now you'll see we have a quadratic trinomial. Okay, so let's factorise first. So x squared plus 3x minus 10. So factors of 10. 10 by 1, 5 by 2. So are any of these adding or subtracting to give us the middle number, which is 3? So we have a 5 and we have a 2. And we need it to equal 3. So if we have a plus 5, take away 2, that will give us 3. So open up your brackets. X in the first, x in the second. So plus 5 with one, minus 2 with the other. And we let it equal 0. So x plus 5 equals 0. So x is equal to 0 minus 5. So x equals minus 5. And then x minus 2 equals 0. X is equal to 0 plus 2. So x is 2. Now, you need to decide here which value you're going to take. And the way you decide is that you always take the positive value. You would never say that the distance is minus 5 centimetres. So your answer there is x is 2 centimetres. I'm just going to write it up here. X is equal to 2 centimetres. Okay, and I'm just going to mark in here, take the positive value. So that's it for week 4. We'll be moving on to a new topic next week. So what I'd advise is maybe pull up some questions that are already in the section on for week 4 on the exam countdown. And I'll also paste in some links as well that I think would be helpful.